Now I said I was going to show you two things under this heading of compound functions. Here's the first one, when you've got the original function on the outside and the inverse function in the middle. Now the next one, I'm going to reverse things. I want you to pause for a second and have a think. What would you expect to happen if you switch these guys around? Have a think, for instance, about all of the other kinds of functions and inverse functions you already know about, like addition, subtraction. Yeah, I don't know. Multiplication, division, logs, and exponentials. Do you expect, if you change the order that you do things in, that you will get a different result?
No, only for the last one.
So here's what we're going to do. These are somewhat more involved, so I'm not going to go through 1, 2, 3. I'm just going to do the first one, and I hope I'll be able to do it in enough detail that you'll be able to do this one and this one on your own thing. But I promise you'll need to actually think quite carefully about these, okay? Because it's not as simple, right? Let's do sine inverse of sine x, okay? Now to help us with this, what I'd like you to draw for me is, rather than these nice mini-sized ones, I'd like us to draw two sets of axes that we can at least go from negative 2 pi to 2 pi. Okay, so you're going to have two whole copies of some different graphs. So I need two of them, and it's probably easier for you if you do them one on top of the other. So you'll have a couple of wide graphs, something like this. The reason we're doing these separately is because you could do them one on top of the other. They are certainly going to be related. But in the past, when I've taught these, people just I get so confused trying to work out which one's which and what am I doing here, and you end up getting a lot of lines flying around. Now what we're going to have is, on the first graph, we're just going to do sine x. Okay? We'll have one copy going that way, another copy going this way, from negative 2 pi to 2 pi. And then down here, we will try and sort out exactly what's going to happen when you put these two together. Okay? So draw me the best sine x graph you can. The more accurate, the better. So if you have a template, sorry, I hope I don't sound like a broken record.
You have a template.
Was it somewhat assisted? Okay.
My tracing is so good.
Right, so here's what we're going to do. Step through this with me. I promise I'll go through slowly enough that if you haven't finished your graph right now, that's okay. I'm going to start with the easy bits first. Okay? And I'm actually going to, no shame in it, I'm going to step through some values here. Okay? So for starters, if I go sine inverse of sine, let's just start with some easy things. How about sine takes angles in it, right? And then it spits out a ratio. What's sine of 0? Not a rhetorical question. 0. It's 0, right? 0. So then you say, okay, sine inverse, I might just draw myself a small one. I mean, you've already got this on your page. But I'm going to draw myself a small sine inverse curve here. Okay. Now, this graph says, okay, you give me a ratio. Ratio 0 is not really a ratio. You give me a value, and I'll hand you back the angle that comes with that. Okay. So sine inverse of 0 then is going to be the angle that goes with that. The answer is 0, right? So I'm going to plot myself a point. Okay. Let's try another angle. Okay. Sine inverse of sine, let's try say pi on 4. Okay. Now I know where pi on 4 is. Here. Sorry, that's pi on 2. Here's pi on 4. Okay. So pi on 4, if I just put a value there, that's an exact value. Sine of pi on 4, of course, is 1 over 2. Help me out. And on your sine graph, let's pop that up here. Okay? So you should be able to plot for yourself. By the way, here's a way to test how accurately you did your graph. Pi on 4, I know exactly where that is with a great deal of accuracy because it's going to be exactly halfway between 0 and pi on 2. Pi on 2, of course, is important because for the sine graph, what feature comes along at pi on 2? The stationary point, the turning point. Yes, both of them. Okay, so that's good. When I map along to here halfway and then go up, what is 1 over 2? Does anyone know what 1 over 2 approximately is?
0.7.
I think it's 0.707-ish. So you should be able to measure up, and that should be about like 3/4 the way up, right? Which for me looks like I got lucky. Okay, so I've just put.
3 sine x.
I've just put pi on 4 into here, right? Then I get to this part. I'm now about to plot a point onto here. It's saying sine inverse of 1 on root 2. Sine inverse of 1 on root 2. So it's asking you which angle in here, in this range, which angle will give you a ratio of 1 on root 2? And the answer is pi on 4. Look, here's 1. So there's my ish 1 on root 2. So, well, that's a terrible scale. You get the idea. Be imaginative, okay? So it's handing you back pi on 4. It's clearly I'm an acute angle here, okay? So it hands you back, when you put in x equals pi on 4, it's giving you y equals pi on 4. So far, so good. So here's a point. So if I call this, coming down here, if that's pi on 4 there, I'm going to go up the same amount, pi on 4. And there's my new point. Okay. Now I could do this quite far, but I'm going to just do one more point in this sort of area. I'm going to do pi on 2 now, and we'll do this a bit quicker. Sine of pi on 2. Sine of pi on 2, 1. Sine inverse of 1. Which angle, if I take the sine of it, will give me 1? And the answer is pi on 2. It's still within my range, so I hand it back, right? Sine inverse will only ever hand you back angles within this range. Does that make sense? Because that's what range means. So therefore, when I put in pi on 2, y is also going to be equal to pi on 2. Now you can test this out, obviously, with more points, but clearly, I'm getting back, like this is what I was predicting. F inverse of a function, by definition, is supposed to hand me back x, right? Do my plots, my points being plotted, look like they're tracing out y equals x? They do. Good. Now I'm just going to take a bit of a shortcut. You can test it for yourself if you like. But this is going to keep on going all the way to, how far can it go?
Negative pi on 2.
Yeah, negative pi on 2, because that's the furthest this range, whoops. That's the furthest this range will go. Okay, so I'm going to go ahead and complete the y equals x line from negative pi on 2 to pi on 2. Let's just draw it out. Okay, so that was the easy part, okay? Looks just like y equals x. Now here is where it gets really interesting. And I'm gonna ask you to put your pens down for a second and just watch this, work through this with me. Like let's do it in our heads, okay? I wanna go past this domain. I should be able to, because when we looked over here, right, the domain restrictions were all about these guys, right? They're in between negative 1 and 1, negative 1 and 1. Okay, this guy's weird, but these have restrictions. What restriction is there on the domain of sine x? No restriction. He'll just go, right? As you can see, he'll keep on waving along as long as he likes. So therefore, I should be able to put an angle like, say, oh, I don't know. Let's try 3 pi on 4. Now I'm going to try out 3 pi on 4 because I know exactly where it should be on my graph. Here's pi on 2, and here is pi. So where is 3 pi on 4? It's exactly halfway in between them. So there's my 3 pi on 4. Okay, pen's out of hand still. Let's see how accurate our graphs are, right? When I put in sine of 3 pi on 4, where's it going to go? If my graph is decent, it's going to come to this same point, right? Because sine x has this beautiful symmetry about it, right? So sine of 3 pi on 4 is 1 on root 2. So then this guy says, okay, you put in this, so that's 1 on root 2. So sine inverse says, okay, sine inverse of 1 on root 2. What angle will give me that ratio? And the thing about sine inverse is it will only ever hand you back angles in here. 3 pi on 4, sorry, is not in this range, is it, right? Which angle is going to give that to you? We've already done this. The answer is pi on 4. So, okay, 3 pi on 4. You can pick up your pen again now if you like to plot your point there. When I ask it for x equals 3 pi on 4, doesn't hand me back y equals 3 pi on 4. It can't, right? 3 pi on 4 is outside the range of sine inverse. Instead, it hands me back that value there. What's going on? What's it doing? Let's do one more, okay? And I think hopefully that'll be enough. Let's do x equals pi. X equals pi, can we do that? This is really easy on our graph, right? X equals pi is right there, okay? So therefore, I should be able to say, when x equals pi, sine of pi is 0. But at the beginning, the first point we plotted, the sine inverse of 0, which is,
0.
bam. Now, I can keep on going, if you like,
It's like triangles. See?
but I'm getting this. Where do you think it will stop?
Never. Oh.
Now, the easy way to say is, I know the range it's going to stop at, because the range has to always stay between minus pi on 2 and pi on 2, right? Because that's all sine inverse will ever hand you. It will only ever hand you angles within that range, right? So I'm going to come down to wherever that is, there, okay? Easy way to work out how far it's gone is, look, this function, it seems to be having copies of itself, right? Copies of itself. From here to here is how far? How far has it gone? From minus pi on 2 to pi on 2, that's pi units, right? So then to go down, it's also going to go pi units. So pi on 2 plus pi, I'm expecting that's 3 pi on 2 down there. And if you like, go for your calculator and put in sine inverse of sine 3 pi on 2. And it'd better give you back minus negative 1.57 blah, 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 blah. Okay? Now we've drawn the rest of this graph. I asked you to do so much of it so that you can actually test out these values over here, right? For instance, what's going to happen if you put in a value like, oh, I don't know. This is negative pi on 2, right? So let's go negative pi on 4. Oh no, that's within the domain. I don't want that. Let's go negative 3 pi on 4. What's it going to do? What is sine of, come on, you can read it off my graph, right? Can't you? Is my symmetry good enough? Yeah, it's negative 1 on root 2, right? I'm picking all these same points. So when you go sine inverse of that, it asks, okay, what angle within this range will give that to me? And the answer is, not that guy, that's outside my range. It'll give me this angle, right? So that's why you're getting this bouncing up, okay? And it's going back and forth, and it's periodic, just like sine is periodic. How's my angle?
Yeah. It's like they came out.
Okay? Now, be really, really careful. We looked at these and we're like, wow, so alike. So alike, right? Like trivially alike. But when you do cos inverse of cos and tan inverse of tan, which you can either, number one, do right now while your brain is fresh in this way we thought about it, or you can wait until the exercise hands it to you, because it does. You will see they actually look substantially different. Mine starts to get a bit bad over there, but that's because I was getting windy. Okay?